Welcome to our presentation called Introduction to Geothermal Heat Pumps and the U.S. Energy Market by Casey Matozovich, Michelle Odajima, and Mike Pechtel. This presentation will consist of three parts. First, a look at the U.S. energy market along with a brief video on this technology. The second section more thoroughly explains what geothermal heat pumps are and some of their benefits. Finally, we will analyze this technology from a business perspective. To fully understand the energy issue, we have to first understand where America gets its energy and how it's used. This chart shows how much of our energy comes from each source. Notice that of the roughly 100 quadrillion BTUs of energy the U.S. uses per year, only 7% is coming from renewable energy sources. What isn't depicted on this graph is that over half of the total U.S. energy used is wasted in transmission lines and system inefficiencies. In the United States, the built environment, that is commercial, institutional, and residential buildings, account for 39% of primary usage, 43% of carbon emissions, 71% of electricity usage, and 53% of natural gas usage. This reference scenario, shown by the top line in red, is the business as usual scenario for carbon emissions for the U.S. What we want to highlight from this graph are the two shades of orange that account for a 65% reduction in carbon emissions just from efficiency measures in electricity and fossil fuels. So it is possible to have more energy efficiency coupled with decreased carbon emissions. Electricity consumption was relatively flat in industry for about 20 years from 1985 to 2005, while growing more than 50% in buildings. Essentially all growth in the U.S. electricity consumption is from buildings, including the generation, transmission, and distribution of electricity. Geothermal heat pumps have the potential to be a big part of the solution. This short video from geothermalgenius.com will explain how this technology works.
A geothermal heat pump system uses the ground you already own to heat and cool your home for less. Geothermal works by using the difference in temperature between the outside air and the ground. The ground is like your own solar panel, absorbing 50% of the sun's energy, which keeps the ground temperature a constant 55 degrees. When the summer sun produces those 95-degree days, the ground remains at its constant 55-degree temperature. In the winter, the ground temperature remains around 55 degrees, even with the snow. To exploit these temperature differences, holes are drilled anywhere from 50 to hundreds of feet deep to house a system of piping known as the loop field. These holes are filled with a grout to improve heat transfer with the earth. The loop field is brought into the home where it connects with the geothermal heat pump. The system circulates a water mixture through the entire loop. In the winter, the water absorbs the heat from the earth, which is then compressed by the heat pump to a warmer temperature and distributed throughout the home as heat. For every unit of electricity used in this process, 4 units of heat are produced. The most efficient gas furnaces are 94% efficient. Geothermal is 400% efficient. The operating cost of a geothermal system can be up to 70% less than conventional systems. In the summer, the same process is reversed, except now the ground acts as a heat sink instead of a heat source. Heat and humidity from the home are pulled out and rejected back into the earth. Cool air is distributed throughout the home, providing air conditioning.